The first step to solving this problem is to read what is given. In this problem, we are given 5 molecules and are asked to draw Lewis structures, find the partial charges and bond dipoles, and how to find the net molecular dipole. The first step is to draw the Lewis structures of each molecule. After finding the total number of electrons, you're going to draw the Lewis structure. Both of the F's go on the outside and the O goes in the middle. You're going to start filling the outer electrons. After finding the number of electrons, you're going to draw the Lewis structure. Both of the F's go on the outside and the O goes in the middle. You're going to start filling the electrons on the outer elements and make each electron has an octet of 8 electrons. After filling both outer elements with 8 electrons, you subtract them from the total amount of electrons to see if you have any left over. In this case, we subtract 20 from 16 and we have 4 left over. You put the leftover electrons on the inside element. The final step to drawing a Lewis structure is to make sure the inside atom has 8 electrons, which is an octet. This is a common mistake people often forget to do, they forget to count up all the electrons to make sure they're 8. Next, we are going to draw the Lewis structures for the remaining molecules. After drawing all of the Lewis structures, you're going to draw the partial charges on each molecule. To find the partial charges of each molecule, you need to look at the electronegativity. The more electronegative element receives the negative partial charge. In this case, for SO3, O has a larger electronegativity, so all of the O's will have a negative partial charge, and the S will have a positive partial charge. Next, you're going to draw the partial charges on each molecule. A common mistake people often forget is they automatically think the partial plus charge goes in the center, but that's not always the case. The next step is to draw the bond dipoles on each molecule. To do this, you go from the partial positive charge to the negative charge, the distance of their difference in electronegativities. This is what the bond dipole will look like for SO3. These are what the bond dipoles will look like for each molecule. Some people often forget that they're not exactly the same lengths depending on if there's the same elements around each center atom, and if they're different, they'll have unequal lengths. An easy way to figure out if the molecule has a net molecular dipole and is nonpolar or polar is to see if all of the outside atoms are the same and if they cancel with one another. For example, in SO3, all of the O atoms are exactly the same, so there will be no molecular dipole and the molecule will be nonpolar. But for OF2, there are 2 pairs of non-bonding electrons on the center atom, which means the molecule is bent, causing the net molecular dipole to be polar. For BeCl2, both outer atoms have the same amount of electrons and there are no non-bonding electrons in the center atom, so this net molecular dipole will be 0 and the molecule will be nonpolar. For CCl4, all of the Cl outer atoms are the exact same, which also means this molecule will have a net molecular dipole of 0. And the molecule will be nonpolar as well. For O3, there is no molecular dipole because both of the O's on the outside are the same element, so they cancel with one another. This concludes that there is only one polar molecule, which is OF2, because of its bent atom in the center. So there are a total of 4 nonpolar molecules and 1 polar molecules. Common mistakes people often forget to think about is the octet violation rule. BE and B both violate the octet rule, so they only have 4 electrons in this molecule. Another common mistake people often forget to think about is counting up the total of valence electrons and just assuming that all of the atoms will have 8 electrons around each one, but that's not always the case.